Alright, so I think we're about ready to get started. This is the SubBottom Data Collection and Processing course, so hopefully you're all in the right place. My name is Daniel. I've been working with HYPACK. I'm a programmer at HYPACK. I've been there since 2014, and I've been helping to maintain the SubBottom processing and SubBottom collection software for the last couple of years. Who here has never worked with SubBottom data? A couple people. Okay, so I'll go over some of the basics. SubBottom operates by projecting a sonar beam straight down, and that will penetrate some layers of Earth, and then those layers will reflect back to the receiver, either mounted on the boat or towed behind the boat. And different frequencies will penetrate to different depths, then different layers of the strata will reflect at different intensities, and we can chart that. That basically, I've worked with Peter before on maintaining the software and updating it, so if he speaks up, it's because he knows a lot more than I do about this than I do. So we support a number of different number of different sonars. Along the left, you'll see the ones that we support with a sort of bespoke driver, and then at the bottom, these are our analog SubBottoms. So who here is using an analog SubBottom? Who here doesn't know if they're using an analog SubBottom? Okay. Then yeah, we'll go over that a little bit. If you're adding a non-analog SubBottom, if you're adding any sort of SubBottom in the HYPACK hardware program, I can actually show you guys. So you'll click the little microchip here, and we'll pretend this isn't here. You'll click on boat, and then you'll scroll through this list, or you can cheat and start to type out the word sub. So you find SubBottom Driver on the list, and all of our SubBottom devices are going to be contained inside this one device. So you'll click Add, and that'll bring it over to the installed column. And then you'll click on Setup, and you'll choose your device from this drop-down. For most of these devices, under the Survey Connect tab, you'll have to either refer to the documentation or contact either HYPACK or the manufacturer for the connection details. Usually it's going to be a network or a serial data connection. However, if you have an analog system, you're going to select the analog option at the very top, and that has its own special setup that we'll get into. But if you have any of the other systems that are not analog, it's pretty straightforward. You select it from the drop-down, you make sure your connection is set to whatever the manufacturer recommends, and then you're ready to move to the next step. If you have two analog devices, two analog SubBottoms running, you'll need to actually add a mobile device to your hardware. And the way you do that is by right-clicking on the hardware option at the top, clicking Add Mobile, and then adding a second SubBottom driver here. You'll also need to add the towfish driver if it's a towed system, and that way we can calculate the position of this mobile, which is being towed behind the boat, using position data acquired from your main vessel. And that's if you're running dual analog systems. So if you are running an analog system, when you start up Survey, you'll have this analog monitor window pop up, and it can be pretty overwhelming at first. but it'll only launch for analog SubBottoms. And so each of these channels here along the, when you click on the I/O channels button, it'll pop up this little window. Each of these channels corresponds to a specific plug on your National Instruments box. And you'll need to select from the drop-down the plugs that correspond to your device. Later on in this presentation, it goes over the technical setup and the wiring and hardware cabling for the analog for the National Instruments boxes. But for now, you would set up your channels in here, and you can name each of the channels as well, so you can actually differentiate them from the rest of your channels. When you're actually in the software, if you have any errors, this big red message box that will pop up at the bottom here, and that can be useful for sort of debugging what issues you might be having. You can click on these actual individual channels to cycle through the different channels on your National Instruments box to see inputs and outputs from them. The threshold, I don't know if you guys can see my mouse. Oh, you can't. That's great. The threshold here, that is the level at which on your, what's it called, the trigger in.
It's the threshold. You have to trigger these devices, and it's normally a 5-volt trigger, but you can actually trigger them at less than 5 volts, so you'll set what the minimum triggering voltage is, and then what's your threshold voltage.
Yeah, and you'll want to set that just above your baseline, because you might not hit that 5-volt trigger just because of differences in hardware and wiring. And when that trigger voltage hits is when an actual ping will trigger on your SubBottom. What else? And these will display the raw analog data as they're coming in, so it's useful to debug if you have like a very low signal, or if one channel isn't bringing any data in. There's a few different types of analog triggering systems. So the external trigger is probably the simplest one. That's when the triggering is provided from something outside of HYPACK. And HYPACK just listens for that trigger and then listens for a return. The internal trigger is when HYPACK is actually calculating and providing the trigger signal to the device. And then SB divisible is when we're doing that, but we're also doing it for 2 devices. So you can actually visualize 2 different signals coming in at the same time and make sure that they don't overlap. So to go over the divisible trigger, you're basically going to set a trigger interval, and that's how often we're sending a trigger pulse to your SubBottom to trigger a ping. That's going to be set for your first output trigger. Your second output trigger is going to be set to whatever that is, but doubled. So if you have a 250 millisecond, if for every 250 milliseconds you're sending a trigger to your first SubBottom, for your second one it's going to send one every 500 milliseconds. And then you can set a trigger delay, and that's just a fixed offset. You're probably not going to set that for your first trigger, unless you have a complex setup, maybe with a side scan at the same time. But for your second trigger, you're going to want to offset your delay so that you don't trigger while your first device is still listening for a return. And this is where we determine how long your first device is listening for a return. So when the trigger hits, we're going to listen for 70 milliseconds. And you can see here we're actually delaying the second trigger by 85 milliseconds, so that we're not listening when the second trigger hits for the second SubBottom.
The reason you do this is to prevent interference between the systems. You're firing two different SubBottoms, let's say a pinger and a sparker together. They will interfere with one another. HYPACK's the only package which actually allows you to be able to acquire two different analog SubBottoms together with no interference between the systems. It's a very clever triggering algorithm that goes into it.
Right. And all of this data is available in the slides, so if you're a bit confused at this point, you can either refer to the slides or come talk to me afterwards and I can go over it in more detail. So the second trigger will listen for 150 milliseconds. The sweep delay is how long it waits after it pings before it starts listening, and that's useful for ignoring the bang pulse mostly. Deep water. So if you're operating in very deep water and you want to ignore 200, 300 meters of depth before you actually start recording, you can set this to ignore that amount of your water column.
Now we use this in the Mariana Trench in 4,000 meters of water.
Mm-hmm.
You don't want to listen to 4,000 meters of nothing before you get to the bottom.
Right, and you're filling a lot of data that's going to fill up your hard drive if you're recording, 4 kilometers of nothing. So there's a table down here with a few basic recommendations for trigger intervals versus the depth. I won't go over them right now, but you have the slides available and you can refer to these if you're using an analog system. Just make sure I got everything. Yeah, and I don't, that doesn't come through very well, but basically this is going to visualize where your trigger is happening, and then the blue line is visualizing how long you're listening for. And the same thing is happening for your second channel. So you can see it's triggering just after the first one stops listening, and then it's listening right until the first one triggers again. Now, we can actually jump into the program. Any questions so far? That's all for analog systems. If you're not running an analog system, you just need to run basic hardware setup, and then you'll refer to the manufacturer for, or to HYPACK notes for specific device setups. So far we've gone through hardware. We've set up our SubBottom device in here, and now we're ready to start our survey. So you'll click on the survey button right next to the microchip, and this will pull up a series of displays. The one we're interested in is our SubBottom Driver display. So what this is displaying is depth over time. So this vertical column you can see here, let me actually change this to is our depth. So you can see that we are operating at about 50 meters of depth in this example. And then you can see the actual SubBottom ping along the right side here. This scraggly bit at the top, that is the bang pulse. That is, your emitter is right next to your receiver, generally close enough to hear the bang pulse, which is the pulse that's emitted where it goes down to the bottom and then bounces off and gets picked up by the receiver. Well, it doesn't go straight down, it comes out of the receiver, and it's going to hit, it comes out of the transmitter and hits the receiver right as soon as it comes out. So that's what we're seeing along the right side here. And then we're seeing the signal drop down and reflect off the bottom here, and then we're seeing it reflect off of different layers of strata down here. On the top left is the device settings button. You can click on this to bring up options for your device. Because we're in playback, we just have a little playback window. But if you have certain hardware, this will actually bring up controls for your hardware. The second option is your display options. So you can either turn on auto scale, which will just scale to display from depth 0, or from the start of your signal to the end of your signal. In this case, it's depth 0 to about 50 meters. If you turn that off, you can actually trim this down a little bit. Let's say you're only interested in 5 meters to 30 meters. You can apply that, and you can see that we've trimmed the depth here to only display 5 up here to 30 down here. And you can see the bang pulse actually disappeared because we're trimming that off. I would recommend not trimming the depth too much, or the top of the depth too much, because you want to be able to see how deep you're running, especially with towed systems. They can sometimes dip, and you don't want that to at the bottom while you're running a SubBottom. So we'll leave that on auto scale for now. Show bottom detect is, so when HYPACK is detecting the bottom, it shows this little, it doesn't come through very well, but there's a red marker right here along the signal trace that shows where HYPACK believes the bottom is. And if you turn that off, that'll just disappear. Makes the signal trace a little bit cleaner. The grid is pretty obvious. Just shows the grid or not. You have grid steps, so you can change when the intervals are, and you can display the grid in milliseconds or meters. Any questions so far? I don't know if I'm going too fast or if I'm not making any sense. All right. The next one is a little bit more complicated. It is our signal corrections window, display corrections window. So the first thing I want to go over is the bandpass filter. And this basically takes the entire, for every ping we get back, it takes the entire sort of frequency return, and it will filter out signal that comes above or below that return. If you're running a chirp system, you generally don't want to enable this, because there's already filtering being applied to the raw signal there's oftentimes filtering being applied by the actual hardware. So if you're running a chirp system, you can leave this off. If you're not, you can turn this on, and a general rule of thumb is you take whatever frequency your SubBottom is running at, whatever half of that, if say you're running at a 4 frequency or a 4 kilohertz system, whatever half of that is, which would be 2, you would set as your minimum, and then double that would be your maximum. So 4 kilohertz frequency system, you would use a minimum of 2 and then a maximum of 8, and that's a good starting place. And then you can actually drag these sliders around a little bit to clean up the signal just a little bit more. Peter, I don't know if you have any more recommendations for getting a clean signal here.
It's a simple band pass. Doesn't store to the data. The raw data is still there. It's just to improve the visual effect of the data, get rid of any baseline noise or any ambient marine noise that might be in the signal.
Yes.
And it helps you with interpretation.
An important thing to mention is that none of the things you do in this window will affect your recorded data. Things that will affect your recorded data are changing settings in the analog monitor if you're using an analog system, changing settings in your in the hardware manufacturer's control software if you're running that alongside your system. But with HYPACK, we like to record as close to what was received as possible and do a lot of our corrections in post-processing. The next thing is TVG, or time varied gain. And what this does is it will take your signal and boost the return as you get deeper into the layers of strata. So the longer you're listening to your SubBottom ping for, the weaker the signal return you're getting, because it's moving farther from the hydrophone, it's passing through more layers of earth. And so in order to actually make out detail past a certain point, you're going to need to apply gains to that signal to brighten the signal up. And we have 3 TVGs, which is kind of unique to our SubBottom software. The first one only affects the water column. So you can see that as I drag this up. Oh no, I thought this affected water column. Oh no, it's because I have this.
So go to G.
One is overall. Okay. One affects the entire column. That makes a lot more sense than just the water column. What I got confused by is if you set TVG1 all the way to the left, so past 0 we have a setting B, which stands for blank, that will actually blank the water column. And you can see along the right here where we had the bang pulse and some noise in the water column, it's now blanking it completely up until it detects the bottom. I like to leave this at 0 so that I can see the water column to make sure that the bottom tracking is correct and we're not actually operating at a depth different than what we thought we were. TVG2 starts at, set this to 0 for now, starts at the water column and starts at the bottom track and runs until TVG3 delay. But if TVG3 delay is set to 0, it will just run from the bottom track all the way through the water column. So you can see here, if I crank this all the way up high, we're applying crazy gains and we're clipping our signal. And we're getting very messy data. But as I bring this back down, we're getting a much more reasonable signal. And if you have a little trick is if you have one of these slider bars selected already, which you can tell by the dotted outline, you can use the arrow keys to sort of fine tune it. And then TVG3 is directly tied to TVG3 delay. And what this does is starting from the bottom track to whatever TVG3 delay is when TVG3 will actually be applied. So, for example, if you wanted to wait 50 milliseconds after hitting the bottom track before you started applying a second layer of gains, you can enter, well, 50 would be too far. I'll enter 20 milliseconds here. And what that's going to do is at 20 milliseconds past your bottom track, it's going to start applying this new TVG, which is, it's useful for operating in very deep water, very deep penetration.
Mainly for boomers and sparkers and air gun systems.
Right. So you can actually apply a second layer of TVG at the 20 milliseconds past your bottom track mark. So you can see if I crank this all the way up, you can see the gain is, it's doing the same thing I did when I applied the TVG2 gain very high, but it's only happening at the 20 millisecond mark past your bottom track, which is set here. So if I change this to 15, it's happening at the 15 millisecond mark. And if you're not using a boomer or an air gun, or if you want to keep things simple, you can just set this to 0, and then this slider won't do anything. And you only have to worry about TVG1 and TVG2. I would say TVG2 is probably the main one you want to focus on, because TVG1 affects, the TVG1 starts at your pinger, and TVG2 starts at your bottom detect. The next thing is your bottom tracking. So the two simple ones are the sensor, which means if you have a bottom track sensor, a bottom tracking sensor coming into HYPACK, we will just use that data for your bottom tracking. The second one is manual. And when you click on this, you can click anywhere in the water column to set your bottom tracking. And it's kind of coming through. You can see the red line here appearing where I clicked, and that's just drawing where it thinks your bottom track line is, or where you're telling it your bottom track is. So wherever you click is where it's going to record your bottom. And the third option is calculate, and that will actually cause HYPACK to look at the signal trace and try to find where it thinks the actual bottom is. And to go through the steps you want to use here. The blanking is your first option. You're basically going to want to set this to blank your bang pulse at a bare minimum. So you can see our bang pulse runs, it looks like it's about 2.5 meters of water. So setting it to 5, that's a little bit over, but not a huge problem. The gate is how far or below, how much higher or deeper your last depth reading it will look for the new depth reading. So I have a gate of 3 meters. So it will account for changes in depth of up to 3 meters for tracking purposes. And then sensitivity is how I would say eager it is to find a bottom. So the more sensitive it is, the sooner it will find the bottom. So if you have a particularly noisy water column, you'll probably want to set this pretty low so that it's not locking onto noise in the water column for its bottom tracking. But if you have a clean water column like this data set, you can actually have this pretty high and be safe. The last one is color by amplitude. Different SubBottoms return different sort of minimum and maximum values for their strength. You would think that they all return stuff in some sort of unified signal strength format, but no, it's just arbitrary numbers that they're sending to us. So sometimes in this data set, we have actually a very wide range of data, a wide range of returns. So you can see that we're getting a signal return of minus 40,000 to about positive 44,000. Sometimes you can have data sets that return data in the range of negative 1,000 to positive 1,000, or even narrower than that. And if you run into instances like that, you might have a very washed out water column. So things will appear very faint because we're looking at, we're expecting a data set between, you know, in this instance, minus 24,000 to positive 24,000. But if we're only receiving data between minus 1,000 and positive 1,000, then it's going to be very, very faint in the water column, or very, very faint in the signal trace. So this just lets you sort of do some fine tuning with that to get a better signal. The easiest thing to do is just hit the auto scale, and that sort of looks at the last couple pings and their signal returns and sets a reasonable minimum and maximum. This warnings will just display if you're clipping your signal or not. But again, this doesn't affect your recorded data, so this only affects your display. And then we have some color options. If you select unipolar, it will only look at the positive side of your signal trace. So that is the right side of your signal trace. If you select bipolar, it will go from negative to positive. Your negative most being white and your positive most being black, with the center being gray, which is why most of this is appearing as gray. Then we've rectified, which takes your negative and folds it over onto your positive. And then color, which takes, I believe, negative becomes red and positive becomes blue. Any questions for this window? Any questions for acquisition at all? So we're about to move on.
Maybe mention the file format.
Yes. So when you want to actually start logging, I don't have the. Okay. When you actually want to start logging, you'll have to click the Start Logging button in the top left, or you can go to Logging, Start Logging. And that will actually start recording a seg-y file. If you're running a dual frequency system, you'll have two seg-y channels, or two seg-y files. The second channel will end with a _002, flagging it as the second channel. And then when you hit stop, it will save that seg-y file to hard drive. And that's saved alongside your positioning data recorded by survey. And I think that's basically it for acquisition.
The SubBottom component of HYPACK, is it separate, like how sweep is?
That's a good question. I think it's included with
Just regular HYPACK?
just regular
It's
HYPACK.
included with Max.
With HYPACK Max. Yes.
You've got HYPACK Lite is not included.
Right.
So the office version is on the Max.
Right.
Office should have the processing side, not the acquisitions.
Yeah. So Office will have all the post processing without the acquisition, which is what we just went over here. And
If you get Max, if you have the Max, it's got the acquisition and processing.
Yeah, or you can buy it as a standard package, HYPACK SubBottom, so it'll only do acquisition and processing of SubBottom.
Yeah. We sell a specific version for SubBottom. So let me scroll through these slides real quick just to make sure I hit everything. If you have two channels of data, you'll have two separate instances of the signal window here. Clear all of this. PowerPoint's freezing on me, and it just crashed. Sorry about that. I don't know why PowerPoint died on me. So in this presentation, we actually go over setting up the National Instruments digital to analog converter. It's pretty technical, and it's pretty hardware or very specific to whatever configuration you're running. So I'm actually going to skip over it. But if you have an analog system like some of you thought you might, you can reference these documents, and it goes over in very good detail how to actually set up your National Instruments box. And it goes over the triggering, which we went over. Alright, so data processing. Once you've run your survey, you can go into the Processing tab, click on SubBottom Processing, and that will bring up our SubBottom processor. It's pretty squished on this low resolution, so I'm going to bring some of this stuff up. So this is what you'll see when you first start up the SubBottom processor. To start a new project or to bring in your data, you click File, New Session, and it will bring you into your raw folder in your project, which is where all of your data has been recorded. And you'll just select the data set you want to bring in. I'll bring in a couple lines. If you've already been editing the data, it'll ask you if you want to bring in the settings from your last project. But we're going to start from scratch here. And you can see at the bottom, there's a little progress bar showing you what it's doing. So this is what you'll see when you first start up the SubBottom processor. Probably not what you're expecting. But if you click these little checkboxes here, zoom to fit width and zoom to fit height, that will actually bring your entire data set into view. So you can see along the vertical axis is your depth, and along the horizontal axis is time, or in most cases is also distance travel. Along the right side window we have a the view tracks, the tracks window, and it actually also brings in your background charts that you have loaded up into your HYPACK shell. You might not be able to see it very well on the projector, but as I move my cursor over the window here, there's a little cross mark that appears in the tracks window. Right about there. That shows where my cursor is in the file, or along the line as I move it.
Can you drop a target from that window?
In this one, the main window here?
Yeah.
Yes, you can. And I'll get right to that. So this window right here is your settings window. It'll appear up at the bottom. If this ever isn't here, you can click on View Settings, and it will toggle the visibility of that window. So if it disappears or you closed it by accident, you can bring it back that way. If you uncheck either of these boxes here, zoom to fit, width, or height, you can actually use these scroll bars to sort of zoom in along different axes. So that's zooming in the X direction or time, and then this one will zoom along your depth. But for now, I'm going to leave this zoomed out. You have your range markers, which are the same sort of things we saw already during acquisition. You can change the spacing of them. You can click on Show Targets, which will show any targets if we have any, and then you can click Target Editing Mode. Right, we need to do bottom tracking first. So, what happened just there was it told me that whenever I mark a target, it also stores the ISOPACK, which is the difference between your, it's the depth below your seabed. Now, we don't have a seabed calculated for this file just yet, so it's going to warn us about that. So to do that, we're going to go to the bottom tracking tab. Most of this you can... Right. So to go back to the, if we remember from the process, from the acquisition, we ran bandpass filtering. We'll want to do the same thing again during post-processing. So you'll click this, and we decided that 2 and 8 were good for our data set. So you'll enter that and click Apply Filter. And again, there's going to be a little progress bar at the bottom. And you can see that that's cleaned up our data quite nicely. And then we can move to bottom tracking.
Boost the dynamic range a little bit.
Right, so we actually want to move along the settings tabs. He helped me a lot with this, so he knows a lot more about this than I do. So the dynamic range, again, when I mentioned data coming in at different rate or different minimum and maximums, you can actually, it'll actually display your minimum and maximum here as well. So this data set's a little bit washed out, so we can actually bring this down a little bit, say to 20,000, and it brings a little more contrast into the image. This is actually a bipolar image. You can tell because the signal trace goes left and right of center rather than just coming right from the left side. So if we select the bipolar option, it's a little funny looking, but that's partly because we're zoomed way out and partly because of our color options. We have selected gray. So if I zoom in a little bit, let me just set this to 1 and 1. You can see a nice return on our bottom track here, or on our bottom return. Another option I want to mention real quick is the trace settings. So the left side here is our signal trace. Right now it's displaying our entire trace based on where our mouse is. If we select Align Trace with Image, it will actually just show the trace based on our image view, so it'll zoom things in to sort of crop it a little bit, makes the signal a little easier to understand. So you can see the black here is where the green dips into the negative, and the white is where it dips into or peaks into the positive. And that's if we display the data in bipolar. There's a few other color options, so you can scroll through these and get a nice sort of idea for the different colors we have. I wonder which one shows up best on this projector. That looks pretty good. If you click on rectified, it will do the same things I sort of mentioned in the acquisition. Rectified takes the negative signal and makes it positive, and then applies your data from there, or applies your coloring from there. And then unipolar will look at just the positive signal for coloring. But I'm going to leave this at bipolar. So just to quickly review, this data, or the dynamic range, is sort of meant to clip your signal a little bit almost, to bring out contrast and to give you a better color range. I'm going to zoom back out and actually set this to rectified, since it shows up a little better on the screen. The next tab is our time varied gain. When you click on the time varied, the TVG button, that's going to apply TVG. This post-processing doesn't have the TVG 1, 2, and 3 sliders. It just has, actually has what a lot of people prefer. There's two different modes. The first one is just your basic exponential gain, and then this is sort of a multiplier that gets applied over time, so you can see that as I crank this up, the signal trace gets increased, and you'll have to apply TVG to actually see it in the imagery. I can bring that back down to 1. And you can see in the signal trace there's this white line. That is the actual level of gain that is being applied. If I crank this slope up, you can see we get a steeper slope the higher I set that, so that's going to apply a gain more sharply the deeper into the water column, the deeper into the signal trace you get. And if I hit apply, you can see the result of that, which is going to be the signal's kind of a little bit brighter, but it gets darker near the bottom. And the other one people like is the user-defined curve, which actually lets you click and drag. You might not be able to see it too well, but there's these red squares that have appeared along the white line that I was just talking about. And you can actually click and drag these to adjust your TVG curve. So you can create a custom curve and then hit apply to see the results of that. A lot of people really like this for fine-tuning their gains. It's especially useful in areas where you have varying types of strata, I suppose. And then you can actually, when you have a curve that you like, this white line along the left here, you can actually export that and save that as a separate file and then bring that into other lines. Now we get to bottom track, the one that I've been wanting to get to. So there's a few options you have in here. The first one, manually pick seabed. When you check this, your cursor turns into this crosshair with a plus symbol, and you can sort of click along your bottom here. You can do that, which is going to take a really long time. It's kind of boring. When you uncheck that, it's going to try and draw that in. Or you can do the auto bottom track. There's a few different types of bottom tracking that we can do. I would just leave it as the default option. The next thing you're going to want to set is your bang pulse, which is this dark spot. We mentioned this before, the dark spot just past your, just at the very start of your trace. So one of the, this isn't a very big screen. One of the easy ways to tell how deep your bang pulse is is to position it just below your bang pulse, and then look at the bottom left of your window. It tells you what depth your mouse cursor is currently at. So you can see as I move that around, that becomes deeper or shallower. So 3 milliseconds is a pretty good depth to clip our bang pulse at. So we're going to set that to 3. Do you know if we want to prefer leaving unfiltered for seabed?
This particular data set, just leave it like that.
Okay. Once you've set your bang pulse, you just click estimate. It'll come up with some random number. You don't need to worry about what the number is. And then you click calculate new seabed, and it'll run through. And now you can see we have a nice blue line following our bottom tracking here. There's occasionally an outlier, like what it looks like right there. If you click on the smooth bottom button, it should clean that right up. You can. Yep. So you can apply a swell correct, which you're not going to see the effects of too much because we're pretty zoomed out right now. But if we got a little closer, you would be able to see it. Let me bring us in a little bit.
Use the mouse wheel.
I'm on a touchpad. Yes, so you can use the mouse wheel to scroll in and out, depending on which of these checkboxes you have filled in, is what the scroll wheel will control. Zoom way in here. You can see that let me actually go a little bit farther. You can see that the bottom is very wavy here, and that's because of the swell of the boat moving up and down. And so if we go back into the bottom tracking tab, if you click on the swell correct button, it tries to smooth that out. Median filter seabed will just try to, I'm not sure what that does.
Just another smoothing method, smoothing the bottom fluid.
Yeah, there's a lot of methods to smooth out the bottom here. Median filter is will just sort of do exactly as it says, which is just to smooth out the line a little bit more. And the last thing we can do, if I zoom back out, is blank the water column, which makes a very nice clean looking image. Makes it look like you had a very clean surveying area. Nice for final products. Just to go through the tabs here, since we're already halfway through, there's a sound velocity tab, so you can set your sound velocity. You can also bring in a sound velocity profile, and that will affect the depth calculations if you export reflectors and targets to EDT and XYZ files, which we'll get to in a little bit. You can bring in tides, which will do the same thing, affecting your depth calculations. The View Tracks window affects this window along the right side. If your tracks window has disappeared, there's a little checkbox here, which will bring it back up. I'll come back to this once we have some targets and some reflectors so we can actually see what those do. You can do a layback calculation, so if you had a towed SubBottom and you weren't calculating your layback using the towfish DLL, you can adjust, or you can actually adjust the layback in post-processing. You have a latency, so if you have when would this be used for latency?
Pipelines.
Hmm?
You're trying to detect a buried pipeline. There's always latency in the SubBottom system. When you're just doing geological work, you don't need to worry about latency corrections. But if you're trying to position a buried pipeline, every time you go to the pipeline, you're going to get a slightly different position based on latency offsets. The SubBottom latency is generally in the order of about half to 1 second. So it's quite a substantial correction. So you can be, normal survey speed, you might be as much as 3 or 4 meters off your pipeline just based on latency.
Yeah.
Worthwhile correction to do. I wrote a paper on how to do this. It's in the sounding better.
So in instances where positioning is critical, you'll want to take advantage of that option. The fence diagram, I'll come back to that too once we have some reflectors and some targets in here. And you can also import border files if you want to trim your imagery to a border file. So if you're only supposed to be presenting data from a certain area and you've built a border file for that, you can bring it into this file, into this tab, and you'll be able to trim your data to your border file. So going back to the display tab, there's a few more things in here I'd like to go over. Now that we have bottom tracking, we can actually enter target editing mode. Close the tracks. To the side. So to get into target editing mode, you just click on the target editing mode button. And that'll turn your cursor into the same crosshair with a plus symbol. And you can use this to mark interesting objects you find, or interesting contacts you find. Are they still called contacts if they're underground? Interesting contacts you found. So wherever you click, it'll mark a target, and those will actually appear in your. Oops! Oh, it zoomed way out. It's a little touchy, huh? Those will actually appear in your tracks window. Color does not appear very great in the projector. So you can go through and click and mark targets to your heart's desire. You can change the target size so they're a little more obvious. If you've marked a target and you would like to delete it, you can hold, while you're in target editing mode, you can hold the shift key, and that plus sign will turn to a minus sign, and you can click on a target and remove it. If you'd like to move a target after you've placed it, you can hold control and do the same thing, and you'll be able to move that target around. I hope that answers any questions you have about the targeting. You can also mark annotations, which are just, actually I'll come back to that once we have a few reflectors in. If you don't have either of these tools selected, when you click on the, actually I might have already done that a little bit. When you click on the data display, you'll start marking reflectors, which are useful for a number of reasons. Doesn't show up very well, but I think I can actually. My goodness, let me bring this up. So you can see, I can click along this layer of strata here and actually mark it as a reflector. So I can go along and the reason I keep going here is because if I get into an area where I've lost contact with the bottom, or I've lost contact with this reflector, I can actually stop this reflector. Get toggle end node. No, I don't want to do it for that one. Sorry, ignore me for a second. If I lose track of my reflector, which I've done right about here, I can actually click over to here, right click, and hit toggle end node, and that will actually skip that one reflector node, and I can continue marking this reflector. I can change the color of the reflector at the top here with this color selector. So if I wanted any color, choose it. There's actually a number of reflectors you can edit. Let's say we wanted to do this one. I can now click along, and I'll be editing this yellow reflector now. Let's say I wanted to do reflector 5. Let's pretend that there was some interesting reflector in here that I'm sure a geophysicist might be able to find more accurately than I could.
You can also custom name those reflectors so you can put whatever geology you think.
So you can click up here, and you can type in whatever you'd like for each of these for each of these reflectors. And the names will be updated. One really interesting thing you can do is these HYPACK polygons. So if you click on this, it will actually fill in this colored area between whatever two reflectors you've chosen. So I've chosen the seabed and reflector 1, and I want to fill this in with red. That hasn't stuck. So that should have come in at 50% color. But you can adjust the transparency to bring more or less of the background through. So if I set this to 80% transparent, I just get a very slight tint of red. And this becomes more useful when you have a number of reflectors, because you can create actually additional ones. So I can choose reflector, say reflector 1 and reflector 5. And I can color this in with a green. And now this is helping to sort of differentiate the different layers of strata that I'm able to identify in this data set. Any questions so far? So we've gone over targeting, we've gone over reflectors. One of the last things I want to go over is the fence diagram. So, actually before I do that, I'm going to go over the view tracks window, now that we have a few reflectors visible. So now you might be able to see that there's a series of colored dots. This is very jumpy. There's a series of colored dots along my line now. And what these are actually the reflectors that I've marked. So you can see that I've selected show reflector number 1 here. So all of my reflector 1 markings are now going to show up along my line in these colored dots. If I actually bring this just to the left, you can see that these colored dots, of course, aren't just for fun. They correspond to the either the depth or the ISOPAC. Currently I have it set to depth, which is depth from your pinger source. But you can also select ISOPAC, which is the difference between your seabed and the reflector. And you can see that the scale has changed from 0.7 to 18.9. Let me bring these sides up a little bit. See what's a little better. And you can also do this for the seabed, which creates a very nice color swath here. Oops. Representing your depth. And you can change the range of your depth here. So we are only going to about 15 meters, say. And now we have a nice colorful representation of the depth on our track line. Lastly, I'd like to go over the fence diagram, which is one of the coolest, I think, parts of the program. Except for when you click on it, it just shows a blank screen. To fill that screen, you actually need to go to File, Export Fence, And we're just going to do the current line for now, and I'll go back and do all lines once I explain what we're seeing. And again, alright. I was going to say it shows a progress bar, but it went pretty quick. Now we have actually this kind of wibbly wobbly looking diagram, but this is actually a 3D viewable display of our data set. It's actually georeferenced, if a bit squashed, so the reason it's sort of wibbly wobbly like that is because it's actually following the track line here. If I rotated it a little bit, you'd be able to see that a little more accurately. Now this comes in more useful when we bring in more lines, but for now I just want to go over it with one line to show you what each of these settings do. The background color, pretty obvious. You can change what you're looking at. You can change your reflector lines, so when we were marking those reflectors, you can bring these way up. You might not be able to see it. Oh. So, you actually need to select which reflectors you want to display. So it's always going to display the asymptotes, which are those colored polygons we see. The reflectors will only show up if you have them highlighted in this list here. And you can change the thickness of the lines so that they appear more obvious. You can also make it more or less transparent. And again, that'll become useful when we have more lines loaded. You can also make it the transparency dependent on the amplitude. So weaker returns will become more transparent and stronger returns will become more opaque. And additionally, you can draw a scale so you can see the depth along the right side and the length along the top. You can make the water column transparent. And now I'm actually going to bring in a few more lines. I think I've loaded a few. Yep. So I'm actually just going to quickly run some bottom tracking. Just because I think the fence diagram looks a lot nicer once you have some bottom tracking. And as you as you load a file for the first time, it needs to go through this little loading process, which you can see in the progress bar at the bottom. But once it does that once, you can switch between all the files pretty quickly, much more quickly than the first load. Right, so now that I've got a bunch of lines, I can go back to the export fence diagram option, and I can click all lines, and that will run its little process. You can see it going at the bottom there. It has to do that for each line, so it can take a little bit if you have a lot of lines. And once it's done, it'll pop up the window. Now you can see all three of our lines here. You can see all three of our lines here superimposed on each other, and that makes it really easy to see elements in the strata.
Change the background back to blue.
Yeah. And if you had reflectors drawn on each of these, they would each show up. It's a really great way to visualize your data. And the transparency helps you look through the data just a little bit.
Daniel, it would be a useful feature to export that to the new 3D KMZ format.
KMZ?
So you can just put that straight into Google Earth.
Let me write that down real quick. Export fence to Alright, just a few other things I'd like to go over in the SubBottom processor. Under each of these options, you can add files to your session. So session is sort of your current instance of your sort of workspace in SubBottom processing. So right now I only have 3 files loaded, but if I had more files I wanted to add, you can add or remove them. There's an option for navigation, so if you click on this, you can actually choose what your navigation is coming from for each line. And if I choose the raw file, I can choose which device I wanted to get the navigation from. But for now, I'm just going to say Y. You can export EDTs and XYZs for your lines. The EDTs, those are just XYZ, or those are just depth and binary.
It's our old single beam format where it's single beam data.
Right. So exporting into these formats lets you bring the data you've processed in this program into other files, or into other editors. You can do the same for your XYZs, or you can do the same for XYZ, and you can do that for your reflectors or your seabed. They give you options to export as depth, the HYPACK, or both. We've already gone over the fence. You can save your current configuration, which is your all of the settings you have set up. You can save screenshots. So the screenshot is will either save just what you see on the screen, or you can save a full line screenshot, which will save a very big image with your entire SubBottom dataset visible. If you do what I do, which is work with multiple monitors, and then move to an instance where you've unplugged your second monitor and suddenly all your windows are off screen, you can hit the tile windows option, which will bring everything over, which isn't super useful if your window is way off screen like this. So what you can actually do is, as long as the SubBottom processor is selected, you can hit F2 on your keyboard, and it'll bring everything back over. These are your delete options if you want to get rid of your targets or reflectors. And yeah, that's pretty much it. There's a simple data display along the right side here to show data about where your cursor currently is. You can see that data will change just a little bit as I move through the data set here. And I think that's pretty much it. I'm just going to go back to the presentation just to make sure I didn't miss anything.
Is there a standard file format that SubBottom provides to export?
Yes, we support SegY files. I think that's it, right?
JSF.
SegY and JSF, so that's edge text format, the JSF file. I think so, SegY is. Even JSF.
JSF's only for edge tick, so if you've recorded something in Discover, we've used an edge tick chirp system, you can just take the native JSF file directly into your processor, which is very handy. You don't need to run a converter or anything like that. But pretty much all the other systems will output CY, so you're safe.
Digitize, you see the map, coloring layers, marking targets. This goes over exporting. You can see the, so this is what the fence diagram would look like if you had done proper reflectors and isopacks.
Right there. Excuse me. Can that be exported to a 3D PDF?
No, not yet, unfortunately.
That
3D PDF, I'll write that down as well.
we can email it to you.
Yes. We've gone over the fence diagrams. they're geo-referenced, so if you've done a grid pattern on your data, it'll actually show up as a grid in the fence diagram, the 3D diagram we were showing. And there's a few video files that are included with the presentations to help show you what you can exactly do with the program. And yeah, that brings me to the end. So if are there any questions?